Alright, so this will be the sketching of kinematics graph. So for the sketching of kinematics graph, we only need to know how to sketch displacement time and your velocity time. So acceleration time graph, we are not required to know. Okay, so let's do this together. Okay, so we have case 1 where a car is stationary. So I need to sketch the displacement time and your velocity time. So alright, so let's sketch. Okay, sorry. Okay, so for your displacement time, since you're stationary, right? So let's just say you start at 0 meter per 0 meter. Okay, so your displacement should be the right here. Okay, of course, if let's just say you are at 4 meter, you can also draw in this manner. So as long as your graph is horizontal, then it's okay, right? Okay, your velocity, since you are not moving, right? Your velocity should be 0. Okay, so acceleration time graph is not necessary for O level. So these are the graph for a stationary car. Okay, case 2, I have a car moving at constant velocity. So I need to draw the displacement time and your velocity time respectively. Okay, so just remember for for constant velocity, you must ensure two things, right? So velocity wise, we must consider both your magnitude and your direction. So magnitude, you must have the same magnitude. So magnitude is the same. Okay. The second is your direction. So you must be traveling in a straight line. So these are the two criteria for constant velocity. So okay, so let's draw the velocity time graph first. Okay, for velocity time graph, is a constant velocity, so it's like this. I'm gonna use this. So this is constant velocity. What about your displacement time? So displacement time should be like this. Okay. Okay, because you are moving. So your displacement, you are moving like you are like maybe from 0 meter, you move to 1 meter, 2 meter, so and so forth. So should be a linear graph. Okay. Okay, now we move on to case 3. So case 3 is where my velocity is increasing now. So I need to draw the displacement time and your velocity time graph. Okay, so first thing first, I draw the velocity time. So how do I draw the velocity time? First of all, I determine, is my velocity increasing, constant, or decreasing? So I'm increasing, right? So the velocity increases. So maybe from 0 to 10 meter per second. But not just that, right? I also need to determine how does it change, right? So since it's changing at constant rate, constant means your gradient is constant. So it means that your velocity is like this. Okay, so this is velocity increases at a constant rate. Okay, what about your displacement? So displacement is a bit more difficult, but not to worry lah. I mean, you will understand when the time comes. So displacement time is like this. It's a curve like that. Okay, so that is for case 3. Okay, case 4. Now is also my velocity increases, but now is increasing at a increasing rate. Okay, so let's draw the velocity time graph first. Okay, so first thing first, velocity increases. But what about the gradient? Increasing rate means that the gradient is getting steeper and steeper. So just now also increases, right, my velocity, but my gradient is the same. Okay, so for case 4, I need to ensure that my gradient is getting steeper and steeper. So it's something like this. Something like this. So you notice that at the start my gradient not so steep, a bit more gentle. Then after that, my gradient gets steeper and steeper. Okay, so for case 4, from case 4 onwards, it's not necessary to draw your acceleration and even your displacement time graph. Okay, because we can only draw the displacement time graph until case 3. Then case 4 onwards is not required, right? Okay, now we move on to case 5. So case 5 is where my velocity increases at a decreasing rate. So same thing, right? My velocity starts from low to high. But what about the gradient? The gradient become less and less steep or more gentle. That's what I call decreasing rate. So the velocity is like this. Okay, so at the start you can see it's steep, right? Then after that, getting more and more gentle until maybe become like this. Alright? Okay, now we move on to case 6. So case 6, my velocity now no longer increases, right? My velocity decreases. So decreases means I'm getting from high to low, right? So I decrease at a constant rate. So since it's constant rate, it's a straight line. So it's like this. Right? So that is for the velocity time for case 6. Okay, now we move on to case 7, where my velocity decreases at a increasing rate. So increasing rate means that my gradient should get steeper and steeper. Okay. Alright, okay, so now I sketch the graph for velocity. So velocity is from high to low, right? Because I decreases, now it's something like this. Okay, so this is for case 7. So you can see that initially my gradient not so steep, rather gentle. So it's getting more and more steep. Something like that. Alright. Okay, last case where my velocity decreases at a decreasing rate. So decreasing rate means my gradient gets more and more gentle. Alright, so yeah, so you can sketch in this particular manner. Okay, so initially my gradient is rather steep, right? Then after that, more and more gentle. So this is how we sketch our velocity for the different cases.